Hey guys, let's talk about percent increase and decrease application problems. This type of problem can be done with a formula. These are the formulas that we use for percent increase and decrease applications. If you're going to let X be the original price, a percent increase is going to be the new price equals X plus the percent in decimal form times X. Okay, and what this does is this takes the new price and the percent, you plug it into this formula, and you can figure out what X is. X will be your original price, which is what these problems are going to ask for. Okay, now you could use this same formula to figure out a new price. If you knew the original price, you would simply plug the original price in where X is and then solve for the new price. Okay, same sort of thing applies for percent decrease. There you'll plug in the new price and then you'll plug in the percent in decimal form and you do a subtraction. You do the original price minus the percentage of the original price. Okay, here's our first little example that I want us to do. The price of a BLT at a local diner is $4.25, including a 7% sales tax. What was the price of the BLT before tax? So what it's looking for here is the original price, or what you would have seen on the menu as the price for the BLT. The $4.25 is what you're going to pay at the cash register when they bring you your bill. And then the 7% just gives you the percentage of the sales tax. Okay, so let's kind of label out what we've got. We have a new price, and the new price is equal to the $4.25. Remember, that's what we're paying at the cash register. The 7% sales tax I need to write in decimal form, okay? You don't want to use the percentage in the percent form in these formulas. You want to use it in decimal form, all right? Okay, so let's take what we know and plug it into our formula. $4.25 is equal to X, the original price that we're looking for, okay, the price before the sales tax. And this is a percent increase because we're using sales tax, which is like a markup, okay? So we'll use a plus sign here. And then we've got 0.07 times X, okay? So now what you need to do, this is just a linear equation at this point, and very much like the business applications we did in class, you'll just combine the like terms, the two X's, and then divide both sides by that coefficient on X to find out what X is actually going to be. So $4.25 is going to be equal to 1X plus 0.07X. That's what we get from that. And then you want to take your calculator and figure out what that is. We are going to round to the nearest cent, since X is going to be in terms of dollars and cents. Okay, that rounds to $3.95. It's like 3.9716 and a bunch of other numbers when you do it in the calculator. Okay, so that is what the original price was. Now, if you think about it, that makes sense. The original price in this instance should be smaller than the new price because we're finding a percent increase. Okay, our price increased by 7%, so it makes sense that the original price would be smaller. All right, let's try another example. All right, here's our problem. You have a coupon for 10% off your bill at MeToro. You pay $16.50 at the register. How much was your bill before the discount? So this problem works basically like the last one. The difference is, instead of having a sales tax markup, we've got a coupon, which gives us a markdown, okay? So we still have a new price, what we pay at the register, and that here is equal to $16.50. We have a percent. In decimal form, 10% is 0.1. So we can put it together like this. We've got the new price equal to the original price, which we don't know, that's our X, minus this time, because it's a discount, it's a coupon, you get a percentage off, okay, 0.1X. And again, what we want to do is combine like terms there with those two X terms, and then we'll divide the 1650 by the coefficient we get on x. Be real careful right here. People tend to miss this one more than they do the other one with the percent increase with the addition. That's still 1x minus 0.1x. So that's going to give you 0.9x. Okay? Now we're going to take a second and figure that out on the calculator. You want to divide 1650 by 0.9. And what we get for that when we work that out on the calculator is $18.33. The 3 repeats, so we're going to round it down to 33. And that is our original price there. Okay? So that's how you work through these problems that are the percent increase and percent decrease problems.